Now we could also look a little bit our reference code, how it's working. If we first look this setup of this initialization side, so we'll bring the code here. Of course, first there are these libraries that we have to include to our project. So here are these libraries. This is the temperature sensor library, liquid crystal library, same as we have been using earlier, and also the Ethernet card library. And this is perhaps something new for you. This is the MQTT library that will be included. Here was this define the pin numbers or the wiring of the LCD display that we have that you could look from the earlier sections. It was done in the microcontroller part of this. And here we create that function for this infrared sensor, and as the MQTT is based for the topics, it's the let's say the topic is the channel number, channel name. So in here we are defining input topic and output topic. It means that our system is listening, is following some of these topics that we will where we subscribe. That system is listening that topic. So we will here we define the names in topic and out topic. We are using both those. And MQTT system is needed also some information. So this is a device ID that we are defining here, and device secret and client ID. Some of these are not mandatory, but at least the client ID and the device ID is worth to give for our system. And this is really important part here. The Arduino will get the IP number from the Ethernet system, but what has to be fixed is the Raspberry Pi's IP number. So in here you have to dig out what is your Raspberry Pi's IP number. The system is not working if the numbers are not correct here, but that you have to find out from the Raspberry side. It's, if possible, it's recommended that you could use these fixed IP numbers in the Raspberry Pi, but if you are using dynamic numbers, each time when you boot up the Raspberry Pi, you have to find out the IP number of the Raspberry Pi and change those numbers to this Arduino side program. This is really important to update these. And here is that string that we are generating the IP numbers. And if we go to setup section, here we define our debugging interface baud rate. This will start the IR sensor to communicating, and in here we are defining the LCD display choice. And now we are ready to booting the device, and we are printing to our display the booting. Wait for a while and then start to wait IP number. It's this fetch IP here is the function that we are calling, that is supposed to be get the IP number to our Arduino system. And when the IP number is ready, then we will connect to MQTT server. This will start the communication. This establishes the communication between the MQTT server and with this Arduino sensor system. And here's the function which will fetch the IP number, which will get the IP number. First we will give the MAC address. We have to define the MAC address to our system. The MAC address definition was here in the beginning of our software. And remember not to use the same MAC address in same network in multiple times, then the system is not working. If you are putting several of your Arduino equipment or devices the same network, please remember to change the MAC address. And here there is the one variable rev, which will we could check that did we were able to boot up our Ethernet card. If your wiring is done in wrong way or whatever mistakes there are, no voltage whatever, it will give an error message. But if it's non-zero value, then you know that the communication between the Ethernet card is working. And here we are only printing the IP number to our local display and to the debugging USB serial display. That's all. With this function we will establish the Ethernet connection and get the IP number. Here's the MQTT connection function. So first we check that if it's not yet connected. If it's not connected, then we make the connection here. Here was this MQTT server IP that we were defining in the beginning of our code, and this is the global port number for MQTT messages. And in here we are defining the callback. That means that when we receive some messages from MQTT server, the callback is defined. The callback function is defined here. And in here, if our connection was okay, then we will give our client ID and device ID to our client software. And if everything is okay, we are printing that connected message to our display, so we know that the connection is done. And here, what is the topic that we would like to listening to our incoming messages is defined here. Here is this in topic parameter that will tell that what is the channel name for incoming message. This in topic was also defined in the beginning of our code base. It's in fact the same in topic. It's also the parameter name and our incoming channel. So now after this, the MQTT connection is ready. We are listening this name incoming messages, and we are ready to send our messages out from our software. Now we have gone through how this setup functionality is working, and now we are going to this loop section. Let's say how the main program is working. First we read the temperature and print and so on. Here's our run loop. First we define here some variables, And this you have to also remember that we have to call this client loop function all the time. This will keeping the receiving messages to be tracked on the real time. And here is that we are reading a temperature value. This is quite simple way. Only call that sensor library function and it will give us the temperature. And then we will put cursors to define the display places where to start to print these numbers, and in here we print T as temperature and the variable that was including that was containing the temperature value and C as Celsius. And then we will, for the MQTT server, we are sending only these integer numbers. So to get also the decimal numbers to inside that message, we will multiply the temperature value with 100. Of course, then in the UI side we have to divide that with 100, but we are not. Then we can use only these integer numbers. It's easier in this kind of example. And here we are reading the voltage. We are calling that standard analog digital converter function and print that value also to display and send that message to MQTT. To send that message to MQTT, there is a send message temperature and send message voltage, which will send the message to MQTT server. And that's all. Then short delay and then start loop again. So it's running in this loop all the time. And here are those sending functions that will send this function will send the temperature value. This in here, this is only to generate a certain structure for the message, and this client publish function will send our message, and the message topic will be this output topic and that's the parameter that was defined in the beginning of the code base, and here is the buffer that contains our message. And here's that how we create that our message. There will be the first this temp and then integer number behind these ASCII marks. And when the string is ready, in here we are sending the message to MQTT server. And the voltage sending is working in the same way. Now we have gone through how our sensor values will be sent to the MQTT broker, and next we will check how we will handle the incoming messages that are controlling our LED. This was the callback function. First we will print these messages to our display, and then we will dig out what is the brightness value in the incoming message. We will check first that if the first letters are PW, then we know that it's our brightness data, next ASCII characters, and then we will we'll define the brightness of the LED and print also that value to our local display, and then we will return from this callback waiting for the next message. And here's our callback in the real code form. Here's the callback function. So what we first do is that we will print to that serial bus, USB bus, that we have received the message, and then we start to processing our message. First here we are allocating enough memory to our buffer where we will store the incoming message. The incoming message is here, or the pointer for the payload. The payload is the message pointer, and that contains our incoming message. And here we will copy our payload content to our JSON buffer here, and then we will put the end mark to end of the message, and then we will print that to our local display, mess meaning message, and also that message to our serial bus. And in here we are giving the memory back. And for the processing, the message processing is started from here. In fact, we are not using the JSON buffer anymore. We are using the payload that was the pointer for the original message to our callback. So in here we are checking is the first letter P and is the second letter W. If it's P W, then we know that it's the command to control the LED brightness. And in here we are picking next 3 ASCII numbers and generate number of those 3 ASCII numbers, integer number of those 3. And in here we are controlling the LED. This ARV is that our value that we have received, and we are writing that value to our output port, which will control the brightness of the LED. This 255 minus ARV is only that we are changing that when the value ARV is 0, then the LED is black, and when the value is 255, then the LED is bright. It's because the LED was connected to plus voltage. So there's it's so-called open collector driver that we are using Arduino. It means that the output pin has to be in 0 logic level, and then the LED is bright, and when the output logic is +5, then the LED is dead, blank. And here we are only printing that value again to our local display and to our serial display. So in here you could use this payload or JSON, but if you're using JSON, then put that free command only in the end of this routine. Okay, now we have gone through also this callback routine. So now our sensor block is now able to receive MQTT messages and sending MQTT messages. Receiving messages are used to control the LED brightness, and sending messages are sending those temperature and voltage information to our broker. So this is the end of this sensor block software functionality.